Thanks everyone for joining our Skanwear Power Hour, the 8th episode. They seem to be flying by. So for those that don't know me, I'm Daniel Henderson. I'm a chartered electrical engineer and I'm the global head of electrical safety and partnerships for Skanwear. Got a wide industry experience, so hopefully should be able to impart a lot of my knowledge onto you guys that are joining, but I'm also always learning. So anything you've got, please throw it back in. Be glad of your inputs. I'm joined today by Wayne Hopkins, who's joining us. He works for Google. He's not representing Google today. He's speaking using his industry knowledge and experience to hopefully impart some of that across onto you guys with his knowledge. I'll pass you over to Wayne now to give you a brief introduction.
Thanks, Dan. Grateful to be here. Appreciate Skanwear putting this together. These are great episodes. A lot of great information going to be discussed here today. As Dan mentioned, I do work for Google, but I do not represent Google, or I am not speaking for Google. This is our industry experiences and to bring to you and clarify that. So grateful to be here again and looking forward to this. And please, as Dan mentioned, this is for all of us. So if you have questions or comments, we hope that you would chime in, and we'd love to hear from you. Back to you, Dan.
Brilliant. Thanks, Wayne. Not clicking then. First hurdle, we've fallen down. Just one moment. We've a slight technical glitch. It was working. The new format's already tripping us up. I'll just cover it. So the housekeeping. So if everyone that's registered will get a copy of the slides afterwards, and you will get the slides and the full webinar sent out via email. You'll get a recording sent along with that. Please use the post-webinar survey afterwards. Let us know how we did. Let us know any topics you want included or to be discussed in future, because that's how we make sure we're getting the content right for you guys that are watching. Make use of the Q&A throughout. Any questions, just put them in. Ben will be moderating that throughout the period. So if there's anything that's pertinent, we will stop and answer any questions that are there. Also, any things that are relevant that for your experiences or inputs, please put them in there because it's how we all learn. If you'd like to be registered for future ones, again, let us know in the Q&A and we can make that happen as well. So just a timeline of 2026. So we've covered power quality and the impact on electrical networks. Again, it's not something that's widely covered. So it was a really good topic to understand how you load them correctly and the impact that can have for you in electrical safety. The last one, we covered substation entry and the risks that comes with that, and then safe selection and the correct selection of PPE for the tasks that you're doing. So now we're looking at electrical switching and how we manage control boundaries on different networks. Down the line, you can see the other ones that are coming along. So we'll have another 5 to go this year. Again, though, they're not set in stone. So if there's something that the masses want that's more important than those or more people asking for, let us know and we can modify that to suit. So the learning objectives today, we're going to understand the preparation for switching activities. We're going to understand the documentation that we're going to use for switching. Look at awareness of the process, followed when switching to ensure the safety of people, and understand the risks of cross-boundary network ownership and control methods. So with that, we're going to start looking at the work planning activity. So again, you'll have different resources out there, but there's lots of different things to consider of what the task is, what the equipment is, where it's located. Can the work be done live? Can it be done dead? They're the questions that you need to start asking right at the planning stage. On MV or HV, we wouldn't do any live working on the equipment, but you might work around the equipment. And again, it's how you can achieve safety by limits. What can you do to keep people safe that are working in the vicinity of live equipment? The examples that we're looking at today, because we're specifically talking about switching, we're not going to do any live work, so we're looking at dead working processes. So in that, we've got a lot of different things that we need to consider. Who's doing the work? How's it being done? What's the supervision levels? what's the impact of the outage? So we're going to look at those in a bit more detail around the preparation pieces now. So communication, such a big thing that needs to be taken into consideration, often overlooked, and often is the thing that causes us the most trouble. So stakeholders, who are the stakeholders? Who owns the equipment? Who owns, controls, and operates the network? Who's going to be impacted by the outage? So we need to know who's involved in the process, who's going to be affected by the works, maybe not in just terms of the actual direct maintenance itself. It might be wider impact. So you might have things like lighting, ventilation, welfare. You might be taking down welfare areas or bathrooms, things like that. You might have other wider impacts. So from my experience, when I've had things like water treatment plants on site, as an example, if they're down for a certain period of time, depending on the type, you might have an issue with discharges into a water course or things there where you go out your consent levels. So things like that you need to consider. What are the wider impacts of what you're doing? And that's where those time scales come into it. Other work activities, we don't often get shutdowns. We know they're a rarity. So when they do come, a lot of people want to make best use of that time. So who else has got work going on? We want to make best use of that outage time, but does it conflict with the work that you've going on? And does it create wider risks? We might have multiple boundary owners. So how do we control the isolations? We might have people working on the downstream equipment, the upstream equipment to try and make best use of the downtime. So we need involvement of others. We need to open up those communication channels. Are the third parties? Are we using contractors? And who's working around or on other network boundaries? So again, that communication piece is key. Wayne, have you got anything to add on the communication side of things?
Yeah, Dan, I would just say it's like during the construction phase, it's so important because as you mentioned, we bring systems down, and then we go into address BIM issues that may have been put in and others get in there. And if we're not communicating when we go to re-energize or first of kind energization, those folks who are working downstream to capture those BIM issues they put in, if they're not communicating, they may not know when we're energizing that they're still on the lineups or, so it's important that constant communication is imperative.
Yeah, definitely. Yeah, really good. Thanks, Wayne. So the outage plan, we're going to look at what that looks like. Risk assessments, a really key piece of everything that we're doing. These might be internal risk assessments, so done within your organization, might be relevant to the task, the switching, the wider things to take into consideration. If we're using third-party vendors, we want to be checking their risk assessments to make sure they've suitably and sufficiently assessed the risks of the work that they're doing. Often we're imparting that responsibility onto them and trusting that they do the right thing. But again, it's still our site, it's still our network, and we've got a responsibility to make sure, applying due diligence to make sure it's the right way of working. We're still overall responsible. With that, we need the method statements that go with that. How are they going to work safely? How are you going to work safely if it's internal? So make sure we've assessed the role, the task that we're doing, how we're going to deliver it, and make sure we've got a clear method of how we're going to work safely and achieve the end results. Competency review, who's doing the work? So is it internal staff? Is it external third parties or a combination of both? We need to be making sure we're doing a suitable review of competencies to make sure the right people that are doing the work have got the right training, the right experience, the right knowledge to make sure that they're working safely. And if that requires certificates, things that have to be provided, that's why these communication channels are key to establish right in the early planning stage. General safety. So we're talking about switching today. So we're talking about achieving safety from the electrical system. In addition to that, we've isolated the system. We've essentially got a work area. What about the other general provisions that we need to take into account? Things like lighting, welfare, slips, trips, and falls, all the other things that make up the general safety requirements for the area. So we need to understand what are those from the risk assessment, and then we make sure we're implementing the general safety responsibilities, who's doing that. Management of staff and contractors. So who's in a supervisory role? Who's appointed is responsible for looking after the contractors, looking after the internal staff? How often are we checking on them? What are the supervision requirements? So we need to have all this as part of the outage plan. So if we have got multiple work parties, we're not tripping over each other, we're not creating other risks for other people, and we're all aware of what's going on. So those timelines and delivery methods are key. We need to know what's going on, when it's going on, and when people are checking in on the contractors, checking in on the workers, and how we link it all back together towards the restoration of our site and our supplies. Wayne, have you got anything to add?
No, I think that pretty much covers it. It
Brilliant.
seems like a lot, and it is, but if you're not thorough and robust and with putting your plans together, you're planning to fail.
Good point. So we're going to talk about boundaries. This forms a key part of what we're here to talk about today. And this is often overlooked. It seems like a very, very simple thing, but boundaries do exist on networks. They have to, because we've got to connect into different systems. So in this example, what we're looking at here, we've got a utility supply or a DNO supply if we're based in the UK. So we've got a simple supply to a site, and we've got to have clear demarcation. So for here, we've got a 66 kV connection to the utility provider. We need to have a clear boundary point where it goes from one person's system to another. So in this one, we've got it denoted as a 66 kV circuit breaker 1 up to the bolted termination on that cable. So that's clear to me that the circuit breaker itself belongs to the utility company, but the bolted connection and the cable that comes onto my site as the owner, I own that, and then everything downstream. So that TX1 and everything downstream is mine. That needs to be documented. It needs to be clear. So if it is, some methods would be a connection agreement. It would say where that point is and typically what the size of your connection is. A good thing is to have a responsibility schedule. So cleared responsibilities between both parties, who owns what and who maintains what equipment as well. This is something I see so often where we've got joint bits of equipment, such as battery tripping units. So you might have a battery tripping unit that is on the circuit breaker that is in the DNOs or the utility substation, which actually belong to you as the owner, and the assumptions made that the utility provider is maintaining the battery tripping unit. But in the event of a fault, you need to make sure that that battery tripping unit's actually going to trip that circuit breaker. So it's got to make sure that your responsibilities are clearly defined and that people are maintaining things like this, because I see this very often happens all the time. So, and ideally we'd have a point of contact. Often we don't, but it'd be great just to have a point of contact. So if we've got any issues around those boundary connections, we can get in touch and resolve that. Multiple boundaries. So here's an example of a renewable site, so a wind farm. Again, this is just an example because I know there's multiple boundary owners there. So in this example that we've got a utility connection, so 66 kV, again up to the bolted termination. So I know that up to that bolted connection on the cable, everything downstream of that belongs to the owner, and that is encompassed within their electrical safety program, and their electrical safety rules are in place on that network. So if I needed to work on that 66 kV to 33 kV TX1, I can't achieve isolation and achieve safety from the system myself because I have no control over that 66 kV circuit breaker one. So this is where I would need to have those communication channels open, utilizing my responsibility schedule so I know who I need to contact and that it's outside of my area of responsibility, because I would need a cross-boundary isolation by the utilities in order to ensure that I've got safety achieved from the system to work on TX1. Likewise, we've got an example downstream where the MV or the HV transformer falls under the owner's or the owner's electrical safety program and safe system of work, but it goes into the wind turbine safety rules boundary at the main Q1 circuit breaker on this example here on WTG1 Q1 LV circuit breaker. So if I wanted to work on the WTG1 transformer and conduct my high voltage or medium voltage maintenance, I would need a cross-boundary isolation to be done by the wind turbine safety rules provider to make sure that that is suitably isolated for my works. So again, we've got to be clearly documented. There's many different ways of doing it, responsibility schedules, SRICs, so safety rules, inclusion certificates, things like that. There's lots of different processes. Let us know in the chat if you use something different. Be good to know. But there's lots of different processes out there. Make sure we've got clear processes for isolation. So you might have wind turbine safety rules have things like approved written procedures, which might require interaction from the HV or the MV provider. Another example of a boundary, here's just a general site where typically, again, we've got the connection agreement up with the utility provider. So at the 11 kV circuit breaker, the bolted termination, so that cable and everything downstream belongs to the client. In this example, the client don't have any authorized persons or senior authorized persons, so they utilize a process to transfer the network over to a HV or an MV maintenance provider that has suitable authorized persons and senior authorized persons to operate, control, operate, and maintain that network. So they'll use a transfer of control as a third party. This transfer of control process, again, it needs to be clear, and it's a transfer of control from the owner across to the third party provider. So those boundaries need to be known. I've had some examples in the last 6 months where a network's been transferred over and some of the guys were continuing to work on the downstream HV or MV apparatus because they just continued business as usual. It didn't impact the work, but in reality, it's not under their control anymore. So everybody in those communications on a transfer of control process, anyone that's impacted by that needs to be made aware, because once it's transferred across, that's all under the operational control of the third party. It's no longer theirs to operate. So again, those measures need to be put in place. So it's something to be aware of. And then another one that we just want to look at, this is another thing that again has caused me issues over the years. Again, same network, we've got our boundary and we're operating. So at the moment, we've got control, operation, and maintenance responsibility for this network as the owner. If we want to projects or if we wanted to have any enhancements, upgrades, or replacement works, or even new buildings. So when we're modifying operational networks, it's still under somebody's control. It has to be. But what I see so often is the owner of the network will just go under CDM or into construction, and this will then go over to the provider. And there often aren't those clear defined areas of responsibility put across. Sometimes they'll use third parties or fourth party contractors to actually do the work in this area. So again, you've got somebody's safe systems of work in place, and then they'll subcontract it out. Then their safe system of work will be in place, then somebody else's. And this happens so often. Who's in control of the isolations? How is it controlled? Who's responsible for those? So this needs to be really clear in the project planning stage. And again, when you've got multiple people working on there, if it was a HV provision, an LV provision, you've got so many different work parties. So it needs to be controlled really well. I've seen quite a few near misses in these examples where guys have been working on the LV side, and then further back at the main LV board from the HV provision, they've started doing energizations, and it was picked up in all those examples I've been involved with, but it's such a recipe for disaster. So with that, now we're talking about construction. I'll hand you over to Wayne, who's going to talk around the risks around the construction and commissioning side of things, and just some considerations to take into place.
So obviously, with construction, you have your initial energizations, or what we call our first of a kind energizations. Regardless of what that is, the simple things that we say simple, but obviously you have to take these into consideration. What is your work area clearance? Also, have you a thorough, robust FOB, foreign object and debris program? Are you making sure that all your tamper seals are in place prior to that actual L3 energizations? This all being pre-energization, so under L2 still. What does your lockout tagout look like? Is it established? Is it clear? Does everyone understand that? What PPE is necessary for the energization? Obviously, you're going to have workers who go in after that energization to watch phase rotation and proper voltages. So they need to be dressed out in whatever category the incident energy has it. And then are your barricades in place and effective, right? With the proper clearances based off of the incident energy. Next slide. So again, with your detailed L2s, prior to that L3, you want to make sure that your teams want to make sure that you have your mechanical checks. Are your torques verified? Are your racking breakers in alignment? Do you have the interlocks that can't be racked when you're closing your breakers? Have you done your point-to-points? Have you done your continuity testing, measuring? Insulation integrity, that's what you're looking for there. Um, and then tug test, right? Important aspect there is making sure that you're performing tug test on your control wiring. Next slide.
Yeah, I mean, just to add into that, we're talking about your pre-energization checks, so your level 2 stuff, which again we link a lot with the first commission and first energization processes. But in reality as well, this is so true for post-maintenance, post-fault. These are all areas that, again, it's not often an electrical issue, not putting down the mechanical guys, but typically it's normally a mechanical fault which causes, shorts and arc flashes, things like that. So the torque verification piece is equally as important after that point to make sure we haven't got any loose connections and things like that, alignment checks. So all these things, although we're saying, the level 2 pre-energization checks, it comes into play post-maintenance, post-fault, things like that as well.
And this next slide here just kind of talks about some of the things that we look for, like with the IR testing, measuring contact resistance, high potting or VLF, CTs, checking your CTs and PTs, and then any secondary injection testing that may need to be done. Next slide. So prior to the actual energizations, you're going to do your final walkthrough, which is important that you're walking the entire lineup down, verifying that no one is still on. As we mentioned before, a lot of times when we bring systems back down in construction, BIM issues may have been put in, and it's an ample opportunity to get in there and correct those BIM issues during that outage. But making sure that prior to the re-energizations that you're walking the lineup down. We see this a lot too with measuring. When measuring has happened prior to the energization, that workers tend to get into a system to work and not realize that measuring is taking place and they get hit with that. So making sure that when those kind of activities are happening, that the team that are doing that, the testing team, is walking that lineup to down. Also checking your control power, right? Making sure that your LV control circuits are working, verifying alarms are working. Then you're going to charge your springs to close those breakers. Um, and then closing clearance to close, and then obviously closing that main breaker. Many times, often with medium voltage, you're going to be using tools such as chicken switches so we're keeping the workforce away from that. So it's clear to understand when we're doing the switching, part of your planning and step by steps, putting your mops together. How are we going to be closing those breakers? Is it a manual close, or is it going to be used with chicken switches and umbilical cords? And then finally, after we do close, and it's never a good process to just run right in and check everything and verify and think it's all okay. We talk about a soak period and verifying that we're listening to items, we're having that soak period, and it's what is that soak period? And then for those technicians who do go in to check phase rotation and voltages, that they are suited in proper PPE, as we mentioned earlier.
For those of us not in the US, the chicken switch reference would be like a remote pendant, or an umbilical where you'd plug it in and take it outside of the substation to operate it from remote. Is there any context to why it's called a chicken switch, Wayne?
I think because we don't do manual racking anymore, where folks are in there and they're actually cranking that breaker in for the manual racking, we now have equipment that's available to us that we can just put that in place and then energize that manual or that equipment to rack in that breaker or rack that breaker out without the worker being right there at the hazardous area.
Yeah, perfect.
And then obviously our post-energization. Now we've done our switching, we've energized the system. Some of us do IR scanning where we're going in and checking for hot spots and verifying that everything looks good. Phase rotation, making sure, that we're seeing the right rotation, that we have the proper voltages. And then lastly, but not least, we're going to document, which some call a birth certificate, signing off that the equipment is new and energized and has gone through all the processes, identifying the dates of the energization and who were the engineers during that.
Yeah, just in additional as well, we talked about earlier was around the use of partial discharge testing as well. So whether it's on first energization or post maintenance, we've obviously taken it out or we're putting it into a different phase. So whether it's taken out of normal operation, we've made modifications and then we've re-energized. Um, Infrared's great, and again, all the other bits are brilliant as well. Partial discharge testing again gives us, as engineers, a whole different raft of information that we can utilize to identify, minor faults, poor terminations, poor joints, things like that. So, an additional thing as a minimum, yes, but yeah, partial discharge, maybe throw that in there as well, just to help us out.
Good practice.
Yep. Thanks, Wayne. Back to me, I guess. So we're talking about switching now. So we've done boundaries, looked at some of the things that we'll do in the work planning. So now we're going to look at, again, a process to follow for switching. Again, if you're doing things differently, let us know because it'll be good. We're going to look at an example, a simple isolation on a single feed transformer to conduct some intrusive maintenance on it's an oil-filled transformer or fluid-filled transformer. And we've got a oil leak on the HV junction box or the MV junction box that we need to investigate. So first of all, before we start, we're going to start. We've taken all the other stuff into consideration around the wider outage that we've already discussed. So we're going to look at the hierarchy of control in terms of switching. So everyone's pretty familiar with the hierarchy of control from a safety perspective. So we're going to try and eliminate a risk completely. The only way we're going to do that is by doing dead switching. It is an option, but it's not always practicable. We could, ask the utility or the DNO to turn off the entire site from remote, just open the breaker from the control room, and then we've got a dead site. It probably isn't reasonably practicable to turn everything off and probably introduces wider risks such as no light and no small power, things like that, which would cause us a bit of a nightmare. So typically we can't eliminate the risk in its entirety. There may be some substitution processes that are in place, but the often goes into, from a switching perspective, obviously falls into engineering controls. So we look at things like remote switching options that we've already discussed. So SCADA, can we operate the switchgear from a SCADA system, or could we use a remote panel outside of the substation where the switchgear is? Could we use a remote pendant or umbilical or a chicken switch if you're over in the US? Could we utilize a remote racking device? So there's lots of technologies out there, either fixed or portable, that we may be able to utilize to take the person out of the equation. We can use administration controls, maybe changing how we work. So again, this is utilizing the correct admin processes. So using switching plans or electrical safety program requirements to make sure that we're mitigating as many risks as we can within that system. And then finally, we're going to look at what PPE requirements we're going to need for the task. So if we're switching from remote, we're going to be having limited interaction with the switchgear. We might have a reduced requirement for PPE for both shock and for arc flash. In this example, we are doing local switching because it's an older network and we've selected the correct PPE for the fault levels and for the instant energy values on that network. So this is the example that we've got, just a simple single feed supply, 11 kV onto a 11 kV to 415 volt transformer. We want to isolate that. So we'll say that we've got a switching program. You might use different things in your electrical safety programs, might be a switching plan, an isolation plan, different terms, many roads, one destination. We just want to make this piece of equipment safe and establish safety from that electrical system to allow us to safely work on it. So we typically have whose is the switching program, where is it, what is it, when are you doing it, what is the activity that you're going to be conducting. Your risk assessment would typically back this up as well. So one person would normally draft this. You might do this in pairs, depending on what your electrical safety program says. And essentially, your plan is just a sequential process of isolating that system in order to achieve safety from the system to conduct that task that you've documented there. So in this example, it's been prepared by someone that's got suitable skills, knowledge, training, and experience for this network and for doing this isolation process. It was me. And then I had it checked by a second person who had a similar authorization to the same level and had the same knowledge of the site. It's no good giving it to somebody else that has no familiarization because they don't understand the requirement of the works. So in this example, we've had it checked. There are scenarios where you might not, where you might have a fault or a call out in the middle of the night where second persons are limited. But typically, we're going to try and plan our works so we've got suitable time to make sure that it's correct. I would expect that second person to pick up on any faults in what I've put together in that process and come back to me to advise we make those changes. And then they would agree to say, yeah, now they're happy. Even spelling errors and anything that could be taken out of context. So if the abbreviations that aren't approved, so if you're using things like shortened abbreviations, they need to be approved in line with your electrical safety program, not just because it makes my life easier of writing them out. So we've got our switching program, and we're now going to look to conduct the first steps on there. So the authorized person is me. I'm in my PPE, and I'm going to conduct starting the isolation. So we've got a start date. It's on the 10th of May. We're now annotating that point. We'll now go through line by line on this plan. Ideally, I would have an accompanying safety person with me. So I'll have a second person coming along. They might support that reading it out to make sure that I've read it correctly. And again, make sure I'm in the right location. So item one, I'm going to go to the control room. I'm going to make sure that the equipment fed off that switchboard has been shut down because I don't want to start opening circuit breakers or switches under load. So I need to try and reduce that load down as much as I reasonably can before I start conducting my isolations. So I've asked the control room to shut this down, and then I got confirmation at 12:01 that it's been done. So the production leader has confirmed that all that equipment has been shut down. I can verify that by looking at the ammeter or by the SCADA or DCS system to see that there's no load on that network. So the next step I'm going to do is I'm going to go to the switch gear because I've got no remote control. And I'm going to open the circuit breaker. Verify that it's opened. I'll then update my switching program. So as I've done that, I've gone to the switch room, make sure I'm in the right place. I've looked at the tally plate to make sure that it's the right one. So incoming TX, LV1, ACB1, and that corresponds with our one line or a single line diagram. And then I confirm that it's open to off. The next step, I'm still in the LV switch room, shouldn't have changed. And then the apparatus says the incoming TX1, LV ACB1, it's the same one that I've just operated, isolate and lock. So opening the breaker, there's not sufficient air gap there to achieve safety from the system and prevent re-energization. So to isolate it, isolation requires a suitable air gap to prevent re-energization, and then we need it to be suitably maintained. So this is where I'll apply my lock and my tag. So in this example, I'm using a caution sign, which is warning against interference because I don't want anybody trying to close that back in whilst I'm working on the network. It could be your example. You might use a do not operate tag. You might have your own specific tags. But in this example, I'm going to use a safety lock. So it's unique with one key. And I've got a caution notice warning against interference. And then I'll update my switching program to confirm that it's been done. You can track the safety lock number if you like. I like to do it just so I know which key I'm getting when I'm doing the restoration. We're now going to go into, so you can see we're going to the next one. We've done steps 1 to 3. We're now going to go to the HV switch room, identify the equipment as transformer T1, feeder VCB1, and we're going to open to off. So visual verification, we're in the right place, push that button, and then we've checked the indication to show that it's off. I'll then update my switching plan with the time of operation and who did it. Same switch room, transformer T1 feeder, VCB circuit, isolate and lock busbar shutters. So this is withdrawable switchgear. It might be different if it's fixed pattern. Different switchgear is going to obviously denote what you do on your switching program. That isolate process might be multiple steps. As you'll see here, it's not as straightforward to isolate it. So as we said before, isolation is that disconnection with a suitable air gap to prevent re-energization. In this instance, it's a full withdrawal of the circuit breaker. So that was quickened up. That obviously took a lot longer to go through that process. In order to lock shutters, we're now going to withdraw circuit breaker. So I think when we're doing our outage and we've got limited amounts of time, all of this takes time, and we need to make sure we're being careful, we're being precise, and we're doing that steady process throughout to make sure we're all operating the switchgear safe. So we're still on line 5 here. So we've removed the circuit breaker, and we're now going to lock the busbar shutters. So those busbar shutters underneath there are still live 11 kV. So we'll now apply a lock and a caution so that we can't actually, a lock and a danger sign or a caution, depends what your safety program says, so we can't actually come into contact with the live 11 kV. Wayne, I suppose a good point on this is there's some gear you come across in the US, isn't there, where it doesn't have lockable shutters. Is that right?
More and more, as equipment gets better and better with technology, the lockable shutters are being coming into play with equipment, which is obviously a good thing to have, especially the way you show it here.
Yeah, it's just really interesting because these are some of the discussions that we're having as we're kind of collaborating between, US, EU, UK, and it's this switchgear here is sort of late 50s. So it's design is such a big thing. I mean, it's a big topic to discuss anyway, isn't it? But yeah, for this example, we're going to lock those shutters so people can't come into contact with the live 11 kV bus bars. I'll then update my switching plan to say when it was done, my safety lock number, and it was me as the authorized person. We're now going to prove dead. So typical process for work on MV or HV is isolation. So disconnection from all sources of supply with sufficient air gap to prevent re-energization. We're going to positively maintain that by applying lock so it can't be re-energized. Once we've isolated, we're going to prove dead. So we're going to do our live dead live checks. Once we've proven dead, we will then earth or ground that circuit to prevent induced voltages and discharge any capacitance in the cable or the primary windings. So that's the process, and we'll maintain that throughout. So if there's any adjacent cables that are still energized, any inductance will discharge straight to ground or straight to earth. So we're going to check our instrument for our potential indicator, make sure there's no damage to it, it's been calibrated, it's in good condition. We're then going to check it against a safe voltage source, so a proven unit ideally. We're going to connect to ground. We're then going to do a check of each phase, and we're looking to make sure that that go or no go. So the indicator isn't illuminated, indicating that there's no voltage present there. On completion, we'll then prove the instrument again using the safe voltage source, so that the proving unit, to make sure that the instrument hasn't failed in operation and that it's still functional. So based on that, we've taken all reasonable checks to make sure that there's no voltage present on those orifices. So again, we'll then mark down when we've done it, who did it. Wayne, I'll pass you over to you because we're going to, now we've done isolation and we've done the proven dead or the live dead live. We're now going to go into the grounding phase. I'll just pass it over to you guys because it's often a little bit different in the US. So if you just take us through what you would typically do at this point.
So, back to the live dead live performance, right? It's important to reiterate here that all of those who are involved with the work must witness that live dead live, and that live dead live has to be done at each work location as per the new NFPA 70 2024 standards. But at this point, once you've proven everything, de-energized, zero energy verifications, and you go to the back of your panels with such like medium voltage, we would install ground clusters and ground clusters. But prior to doing that, right, medium voltage can have a capacitive charge that you have to dissipate through grounding sticks or whatever. But it's important to make sure that you take out that capacitive charge and then install your grounding clusters. Grounding clusters are important to number, as you have a picture here, within your MOPS, because when you go back to re-energization, we have seen sometimes where grounding clusters get left on equipment, cabinet doors get closed, maybe they don't put signage like we see here, where signage is on every piece of equipment, bolted or non-bolted hinged cabinets. So those, if they're not there, and you don't have a trackable grounding cluster, you may forget that those grounding clusters are there due to the speed or whatever that is happening with the project. And then you re-energize the system to the ground of those clusters, and that can obviously lead to problems. So having a good tracking process for your clusters and is important to do here. And I'm
Yes.
sure we've seen a lot of industry best practices around grounding clusters, installation and removal, tracking and such. Love to hear what others are doing out there.
Yeah, it's really interesting. From our side, UK, Europe, probably most APAC. If we typically would go into the next function, which would be using the switchgear to ground the circuit, like our circuit main earth or circuit main ground. But again, anyone that's utilizing portable grounds or portable earths to ground your circuits, yeah, let us know if what you do, any processes you follow in the chat. Just be really good to know. Obviously, this example is where the distance from the switchgear to the point of work, so the transformer, isn't that far. Again, there are going to be considerations where you've got longer circuits and your circuit earth or your circuit ground for the switchgear won't achieve that zone of protection. So we might do the circuit main earth application at the primary substation like we're going to do now, but then at the zone, we might establish a zone of work and apply a portable ground closer to the equipment. We might even put on a comfort earth or a portable earth at the location as well, just to give us that belt and braces that we know it's definitely going to discharge stored any energy and capacitance that might be induced into the cable. In that video we've just watched there, the individual's gone around to using the US example that Wayne's just talked us through. The individual's gone to the back of the panel. Now, after he's proven dead, he's then visually verifying that the labels on the back covers on each panel correlates with the exact panel ID on the front, because sometimes these can be taken off for maintenance and be put on the wrong one. Going from the front of the panel to the back of the panel can often cause confusion. So you just see a label, take the cover off, and we're not isolating this whole board, we're only doing one circuit. So in this example, we could take off the wrong cover and come into contact with energized parts. So the individual is going to check each panel, make sure that it all corresponds with the right one. And then what they've done is they've put danger live notices on everyone that's still live after they've verified that with the corresponding ID on the front, so that is not part of the work. We've then put a alternative, so this is a caution sign indicating that this is a part of the isolation, part of the work, and then the individual will go through what Wayne just said, they'd work on that correctly identified panel.
And could I just add, Dan, that that's extremely important in what we see, especially with data centers and lookalike equipment, and numerous lookalike equipment, right? So making sure that we have the right labels, the right correct nomenclatures, so we are opening the correct cabinets. Because the front of the cabinet, you could have to walk outside of a building and go to the back side of that building to enter the back of the cabinet. And by the time you get there, if you're not tracking that properly, you could end up inadvertently opening an energized cabinet and exposing your workforce to that.
Yeah, it's so common. So in this example, we're going to use the switchgear to ground the circuit. So we've put that switchgear into the circuit earth or circuit ground position. So the front contacts are going to enter the circuit orifice and come into contact with those spouts. And on the back, we've got ground pins or earth pins which connect to the substation ground. So then they're both in contact. We'll make sure interlocks are correct, charge the springs, and we'll close that circuit breaker to then ground everything from the primary side of the transformer, the cable, down to the substation ground through that circuit breaker. So we would then put that safety lock onto the circuit breaker, onto the trip function, so it can't be removed. Because if we open that circuit breaker, we're then going to remove the earth or remove the ground. We would apply again our notice on there to warn people that it is a safety precaution to protect people, so it can't be removed. And then I'd update my switching program to say the time it was done, the key that was utilized, and then I'd complete my switching program with time of completion, who did it, and a little signature to take some responsibility. And then I'd make sure that the keys are safely retained. In this example, we're going to use a key safe, but you might use an ammo box, you might use a fixed lockout tagout location. It just depends whatever your electrical safety program has in place for your sites. Again, now we're going to look at conducting the work. So this is the final step of the process that we're going to cover. I'm looking to use a permit to work document. Again, this is very UK and European utilized. You might do things differently in your geographical location. Again, let us know in the chat how you utilize and set people away to work at the point of work. So our work, as we said, was so on this document, this is going to be a clear allocation of responsibility for some works to be done. So in section 1, you'll see location, so where it is, what it is, and the works to be done. So we're going to conduct electrical maintenance in line with contractors' RAMs, risk assessment and method statement that I've personally reviewed and accepted. I've then put in there the safety precautions that I've taken to achieve safety from the system. So I've got the 11 kV switchboard circuit breaker is isolated and the busbar shutters are locked. I've then done the same thing with the LV switchgear. The incoming LV circuit breaker 1 is isolated and locked. And then at the 11 kV switchboard, transformer T1 feeder, VCB1, circuit earth or circuit ground has been applied, and that's been locked. The caution signs have been affixed and will be on for the period, the full period of time. So now we're going to conduct work on some HV equipment, but we haven't proven dead at the point of work. So typically we would prove dead and then work. But in order to get there, we need to do some work by removing a cover to prove dead. So it's a little bit of chicken and egg. So in this process, we would issue a permit to work to start the work. And I've got a further precaution in there, which says further precautions will be taken during the course of the work. Once the permit to work is issued, number 1 transformer HV junction box cover may be removed. Once removed, all works are to cease until proven dead. Once proven dead, then the works in section 1 of the safety document can continue. And all the adjacent switchgear will remain live for the duration. Don't touch or interfere with anything adjacent. So it's clear that this is the only piece of equipment to be worked on. We then go through the issue process. So as the authorized person, I'd be signing to say that those safety precautions are suitable for the works in section 1. The person doing the work would receive a key, or you might use your own lockout tagout key in that process. Just depends what your electrical safety program says. They're going to put a portable ground on at the point of work. They then sign. So this is the issue side of things. And then the receiver, so the person doing the work, a contractor, is then receiving that, and they know their responsibility is to do that work in section 1. So we've issued the safety document. We're now going to remove that cover. Again, we've got the right PPE. As Wayne said earlier, we've got people watching who are going to be conducting the work to make sure that it is the right location and they can witness that. So we'll safely remove the cover. We don't want to drop anything inside. You'll probably notice the tiny conductor size. This is done in a safe environment. We don't want to risk anybody for training. So we're then going to do our live dead live check using a voltage source. We're then going to prove dead, that the absence of voltage check at those conductors, and then we're going to prove our instrument. Little nod there. Happy with that. So then we've kind of gone through that process. So in that summary, we've gone through how to prepare for switching activities. We've looked at the process to follow when conducting switching, and an important piece is ensure that the inter-system boundaries are managed effectively. So the next thing that we're going to look at in 6 weeks' time is going to be the differences between UK and USA comparisons in electrical safety. I know we've touched on a bit. So I'm going to be joined next time by Lanny Floyd and Steve Quiet from Bowtie Engineering, who's going to be supporting that. So we'll now, with that, we'll now go out to Q&A and see if we've got any questions or great pieces of knowledge and information from you guys.
Dan, it looks like there's a question in there about explaining what the L levels are, or levels of commissioning. So obviously we have the 5 levels of commissioning, starting with level 1, which is your factory witness testing. Level 2 would be bringing equipment in on site, putting it in, performing your inspections, your bolt ups, your terminations. Level 3 is your actual energization of that equipment. Level 4 is following the manufacturer scripts for operation, making sure they're performing as adequately as they're supposed to. And then your level 5 is your IST, integrated system testing, and then hand over to the client.
Yeah, so there's multiple steps in there, isn't there? But that factory acceptance test, a key bit with that is making sure someone goes along to that who's got suitable knowledge and experience. So in large projects, the electrical person or the person that's responsible for the project, the key project manager might not be electrical. So if you are doing a FAT for switchgear, transformers, things there, it's important to make sure you've got a good representative to make sure the requirements for the FAT is being done. But there's quite a few steps to level 2, Wayne, isn't there? It's probably one of the most important bits to that pre-energization piece.
Absolutely, because once you put everything together and then the inspections happen, it's a good practice to tamper seal. For example, we see a lot of tamper seals in place where a commissioning agent will do their final inspection, put a serialized tamper seal on that equipment, and then part of the L3 energization mop has a step in there to say, is tamper seal in place? Is it this serialized number? And if not, then you stop all work and perform your back out to discover why is the seal not there? Why has it been cut or whatever? So, a lot of work in that L2, but honestly, the L3 is the most hazardous because that's where we're actually talking about today, the actual switching and the energization of that equipment.
Yeah, I mean, as you mentioned, all that level 2 stuff, if that's not right, that if we're not doing those checks and verifications, the level 3 is, that's where the risk, and the likelihood then goes up a lot more, doesn't it? If we're not making sure we're doing suitable level 2. So it all goes hand in hand, doesn't it? But that level 3, like you say, is the most important. It's where there's an increased level of risk. But if we do everything that's in level 2 checks, it just mitigates as far as we reasonably can, doesn't it, before we do that?
And back to the factory witness testing, more and more we're seeing integrators um, uh, providing skids, electrical skids. And instead of a typical factory like other Siemens, Schneider, and others out there, we are seeing equipment being put together at an integrator and on electrical skids, right? It's important to have those folks there at those places to verify, proper component, as well as gathering the training necessary for the operation of that equipment from those factory testers.
Yeah, perfect. We got any other questions there, Ben? Right, well, with the time that we've got then, I'll thank you and just remind you that we have our electrical safety conference at the Royal Institution in London on the 9th of July. It's a one-day event. We're looking quite heavily at field safety, so field service safety. So the guys are actually going to site, conducting the works, whether they're internal or external. We want to have quite a big focus on the people that are actually going to site. They're going out every day, making sure that we've got suitable supplies either to our domestic work site, just around where you live geographically. Just need to make sure that those guys are going out there every day, interacting with the systems, maintaining the systems to make sure we've got the great infrastructure that we've got. So we want to have a lot of focus around that to look at where those risks are and how we protect our people. But great to have you there. It's at a great location. And then secondly, we have our monthly electrical safety calls where we get together and continue what we've done at previous conferences, looking at key work streams. If anybody wants to join any of those, we can get the information out. You just let us know in the Q&A. I'll thank you very much for your time. If there's no more questions, we'll let you get back to your day.
Thanks, everybody.